So, hi everyone, and in this video, we are going to discuss this LeetCode daily challenge, redundant connections. So, you're basically given an undirected graph and you're given some edges. So, this is not an undirected graph, this is a tree. Like a tree has n minus 1 edges, and they're saying that they have one more edge, one additional edge in it. So, you have a connected graph and connected undirected graph, and you have one extra edge in it. So, basically, it is a tree with a cycle. So you need to remove some edge, like some redundant edge will be removed, and the graph still would remain connected. So which edge you can remove? So suppose this example is here. In this case, you could either remove one edge 1 to 4, or edge 1 to 2, or edge 2 to 3, or edge 3 to 4. Like in these four, you can remove any one, and the graph will still remain connected. But they want you to output the edge which is the end of this list. Like you could remove 1 comma 2, you could remove 2 comma 3, but which is the last one in this list which you can remove? That is 1 comma 4. So you have to output 1 comma 4, and the constraints are pretty small. N is only 1000, so O of n square solution will work. So what you can do is uh, you could pick a you could create an adjacency list first, like convert the see this tree as a graph and have a visited array, and you remove one edge. So removing one edge means that you mark it visited, or you don't need to mark it visited. You can, like, while doing DFS, don't go through that edge, and do this for each edge. Okay, and after running one set of DFS, if your graph has become disconnected, then that edge cannot be removed. And if it is still connected, then removing that edge can be a possible answer. And we will traverse this edges array from the back, so that the first time we found an edge which after removal still keeps the graph connected, then that will be the answer. So you can start coding this solution. First of all, you can calculate the size of the edges, like how many edges are there, and you can create an uh, adjacency list. And you can add these elements to this. Something like this you can do. So this is how you can create the graph. After creating the graph, you can have a visited array. It will be initialized to 0. Then you can start traversing the edges from backwards, and you can get this edge. So like this you can have. Now what you can do is you can run a DFS, or what you can do that you can write this visited array inside this loop only, or you can again and again initialize it to like 0. So like this. Yes, now you can start. Now again apply DFS from node 0, and since this is a tree, so all nodes should be connected. So from 0 also you could traverse the whole graph, and you can pass these edges as well, and the adjacency list and the visited array. Okay, this you can do. You can try the DFS method. Void DFS. This is your incoming edge. I mean incoming vertex, and this is a visited array. So you can mark your ith node visited, and then you can go to the adjacent nodes. And uh, if your like your basic DFS would be like if not visited to, then you will visit it like this. Okay, but yes, like you don't, if you're as you're doing this DFS on the assumption that UV edge is not present in your graph. So you'll check like if this is the UV edge, then you don't want to like use it. So if I equal to u, and you can do like this, if I equal to u and 2 equal to v, then you just want to continue. You can also check vice versa, because the graph is directed. So you can say if I equal to v and 2 equal to u. Okay, after doing this, your boolean solution, and you say that yes, a solution exists, then you will traverse the whole vector visited. If visited I is not true, means after running DFS there is some node which is not visited, means the graph is disconnected, then the solution will become false. And if this solution is false, if this solution is true, like if the graph still remains connected, then removing this edge won't cause a problem to us, so we can return this edge is the answer. And you will never go out of this. You will find the solution in this for loop only, so you can return anything. Okay, I'm getting a wrong answer. Why am I okay. These edges are one based now, like from 1 to 1. Now it should work. So you can submit the solution. Yeah, so thank you for watching this video. I hope you like it, and please subscribe the channel and hit the bell icon to receive any future notifications. Thank you.